All right, let's do another math assignment. Hopefully I'm not doing something you've already done. So, all right. First thing we're gonna do is find the zeros. Find the zeros. So if we have a problem, let's say x squared plus 6x plus 9. All right, what we're gonna do is we're just gonna break this down into its original pieces. So it's x plus 3 and x plus 3. If I solve this and did FOIL, x times x is x squared, blah, 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 that gives me this. So I just broke it down into its original piece. From this point, I just make each side equal to 0 and solve it, and then that'll give me my final answer, what I'm looking for. So x plus 3 equals 0. These are the same, so I don't really have to do them both, but I'll just show you. X equals 0. X equals -3, and this will be the same exact thing. So x equals -3. And all I'm doing is subtracting a 3 from both sides. All right? So let's do another example. Let's try x squared plus 4x minus 12. All right, once again, break it down. I know they're going to be x squareds on both sides. I just got to find something that's going to, when multiplied, is going to give me 12 and going to add to give me 4. So let's try a 6 and a -2. 6 minus 2 will give me the 4, and it'll be positive. And then 6 times 2 is 12. So, and that'll give me a negative. So x plus 6 equals 0. X minus 2 equals 0. X equals -6. -6 on both sides, right? And x equals 2. I'm just adding 2 to both sides. And then that'll be my answer. Let's try one more that's a little more difficult. Let's try 2x squared plus 4x plus 2. Now this time, when I have my parentheses, I'm going to have x's, but in order to get this 2, I have to have two numbers that multiply to each other to give me that 2x. So really it's just going to be 2 and 1. So I'm going to make one of these a 2x. And then to get the 2, it's a number times a number, right, to get to 2. So I know it's probably going to be a 2 and a 1, so I just have to make sure that I get a 4 on one side. So I'm going to try a positive 2 and a 1. And that should work. All right. From this point, I just solve again. So 2x plus 2 equals 0 and x plus 1 equals 0. Over here, I got to subtract the 2 on both sides. 2x equals -2. X equals 1, -1. Remember, to get rid of this 2 from this x, I got to divide on both sides. So I divide on both sides. 2 divided into 2, and it's a negative, gives me -1. All right, on this side, I have x is equal to -1 also. And that's it. Page 2. Alright, so if we have a problem that says find the coordinates of the vertex for the parabola. All right. So first thing I need to do is just find the formula. All right. So what I'm looking for really, if I see f of x is equal to, well, the formula is a x minus h squared plus k. All right, so let me give you a problem here. F of x is equal to x plus 3 squared plus 1. All right, so let's look at what we got here. A is basically either going to be a number or a sign. So in this case, A in our case, it's just going to be positive, right? There's no negative sign or anything like that. So we know right now A equals, let's just say plus 1. All right. H, we know H is 3, but when I plug this into the formula, see the negative? I got to use that negative sign. So, and then I know K is going to be this 1. So this is easily lined up. So all I really have to do is just kind of plug things up. All right. Also, right here, let's do a couple things. I'm going to put an arrow. Hopefully this doesn't mess you up. Arrow. All right. If this is a positive number, the graph is going to open up. If it's a negative number, it's going to open down. So open up, open down. All right. Over here, your H and your K, that's basically your X and your Y, and it's the vertex of your parabola. All right. So this is your X coordinate, this is your Y coordinate, and it's the bottom of your parabola. All right, so let's go ahead and solve this. Let's plug it into this formula. X minus H, we know this is our H, right? So it's, I'm gonna put it off to the side. There it goes. X minus 3, because I'm plugging this positive 3 into this negative spot, so 3 squared plus K, in our case K is 1. That's pretty much all we need. The vertex we already know now. So our X is negative 3, our Y is 1. That's all we're looking for, just the vertex. Find the coordinates of the vertex for the parabola. Vertex, that's all we're looking for. Bam, done, easy. Page 3, graph the parabola. All right, so parabola equation, A x squared plus B x plus C. All right, so first thing, let's give you a problem that you can kind of look at. So let's go negative x squared minus 2x plus 1. All right. That's our A, that's our B, and that's our C. All right. So first thing we want to do is just kind of figure out, since we're graphing it, we need to figure out which way the parabola is gonna go. So step 1, is it up or down? All right. If it's a negative number, it opens down. If it's a positive number, it opens up. All right. So what do we got over here? Whoop, whoop. We got negative, so now we know it's going to open downwards. All right, so when we're trying to graph it, we already know, hey, it should be going down. Let's just make sure it does. All right, step 2, find the vertex. All right, to find the vertex, we're going to use this. We're going to use x equals minus b over 2a. Now, we've already plugged in what our b's are and what our a's are. Here's our A, here's our B. So all I have to do is just plug some numbers in. X equals negative, that's the negative, negative 2 over 2 times negative 1. All right, the negative 2 is my negative 2 here. My negative 1 is this x. X is really just a placeholder of 1 and it's negative. All right, so now I can go ahead and solve for it. So what I got is 2 divided by negative 2 times a negative, right? So this is going to actually give me a positive 1. Negative 2 divided by 2 gives me positive 1, and then I hit it with this negative sign. So x equals negative 1. All right. Once I do that, then I can plug it back into the formula. So number 3, plug back in. All right, let's go back to our original formula up here. This is our, I'm going to plug this negative 1 into everywhere I have an x and just solve. So negative times negative 1 squared minus 2, negative 1 plus 1, and I'll just say that equals y, because I already got my x, I need my y, and then I can go ahead and solve for it. So negative 1 squared is 1 times 1 gives me negative 1. Negative 2 times 1 gives me positive 2, and I have a positive 1 equals y. All right, and then that's 3 minus 1, so that's 2 equals y. So now I know my vertex. Whoop, let's bring that up so you can see. Sorry about that. That's just what I solved right there. All right, so I got my y, I have my x, that's my vertex. So I know my graph is going to start at negative 1, comma 2. So let's put it down here. Negative 1, comma 2. That's my vertex. All right. Now from this point, all you really have to do, since you know your vertex and you know that your graph is going to, if it's negative, it's opening down, you know it's going to go down. All we have to do now is just plug in some points. So what I suggest is you go back to your original formula right here and just create yourself a an x and y chart, and then just plug in numbers for this. So like you could use 0, so plug in 0 for every x, and then solve for y, plug in 2, solve for y, and then that'll give you points to solve your graph. All right. Page 4. All right, midpoint. Midpoint of line segment. My camera's not zoomed out enough, so sorry about that. All right, first thing is obviously the formula. X1 plus X2 divided by 2, comma, Y1 plus Y2 divided by 2. All right, so all we have to do is just plug these numbers in, and then that'll give us the midpoint of a segment. So as an example, if I have 1 comma minus 6 and negative 8 comma negative 4. All right, I can go ahead and just plug these in. Like I said, I always label these, so x1, y1, x2, y2. That way I don't get confused. So x1, so 1 plus negative 8 divided by 2, and then comma y1 minus 6 and minus 4 over 2. So over here I have negative 7 over 2, comma. This is negative 10 over 2, which gives me negative 5. So that's the midpoint. That's all you have to do. Pretty simple. Page 5. There it goes. All right, now there's going to be some problems. It says like if f of x equals 5x plus 2 and g of x equals 2x, find whatever. It might say f times g, and it might say f plus g, or it could say f divided by g, or g plus whatever. Basically, all you're doing is just plugging in these values. So let's say this is equation A, this is equation B. All right, so let's do A first. F times g. This is f, this is g right here. All right, so all I have to do is everywhere there's an x for the first one, f times g, this is what I'm looking at, just the x values. So wherever there's an x equals 2x. So I'm just going to plug a 2x in there for this one. So 5 times 2x plus 2. All right, so 10x plus 2, and that's all I'm looking for. That's the first one. Second one, f plus g. All right, so here's my example. All I'm going to do is 5x plus 2 plus g, 2x. So I'm left with 7x plus 2. All right, so that's all you're doing on these problems. Just find the x and plug it in. If it's adding or subtracting, you just kind of follow this route right here, and that's it. All right, let's go down here. Write an equation. And slope-intercept. Form. All right. Pass with a line passing through something. Let's see, for line, whoop, passing through points. In this case, let's say 2, 2 and 4, 5. All right. So first things first, you need to know what the slope-intercept formula is. So slope-intercept, and that's just y minus y1 equals m x minus x1. All right. Now we can almost just plug these in, but we need that slope. So the first thing we have to do is find the slope using these 2 points. So remember, the slope is just y2 minus y1 over x2 minus x1. There it goes. All right, so let's find that first, and then we can solve the other one real quick. All right, so back over here, I have x1, y1, x2, y2. All right, so let's see, y2 is 5 minus 2, and x2 is 4 minus x1 is 2. All right, so that gives me 3 over 2, which is my slope. There we go. So now I can go ahead and try and solve what they're actually asking me. All right, so all I have to do is just plug this information into this formula and then just solve it. So let's pull it off to the side so I can see a little better. There it goes. All right, so y minus y1 is 2, so minus 2 equals m. We just solved for m. M is 3 over 2. Times x minus x1. x1 is 2. There it goes. All right. Then I can go ahead and solve for it. So y minus 2 equals 3 over 2x. All I'm doing is multiplying this in. 3 over 2 times negative 2 is going to give me a negative 3. And basically what I did was, I'll find a spot. There it goes. 3 over 2 times 2. 3 times 2 is 6. That's 2. 2 into 6 is 3. Remember, it's a negative, so that's how I got the negative 3. All right. All right. Now I just got to get this 2 by itself, or the y by itself. So y equals 3 over 2x All right, this becomes a positive, positive 2, positive 2. So that gives me negative 1. And that's the answer they're looking for. So find the slope real quick, plug the slope in, insert your y1 and your x1, and then just solve it. That's all they want. Almost done. Page 6. All right. Let's see. Finding domain and range. All right, and then let's see, your constants. Constant increasing and decreasing. And let's see. And then here, that's 1, this is 2, this is all 2, and then 3, is it odd or even? Whoop, there it goes. All right. Okay, remember the domain? I'll just go over this real quick because I think you guys get this one. The domain is on a graph. Here we go. On a graph, the domain is how far does the graph actually go, all right, in the x direction. The range is how high and how low does it go. So if you had a graph that started here and ended here and went up like this, that would be the domain, however far it was, you know, from negative whatever to positive whatever. And then the range would just be the distance in between, all right? In between the highest and the lowest point. All right. Constant, if there was a flat part in the graph, that would be your constant, right? Because it's constant, it's the same slope, it's just constant. There you go. I don't know how else to say it. Increasing, graph going up, decreasing, graph going down. So on these, all you have to do is basically just find the points where it's either constant or where it's increasing on the x-axis. All right, so if you had something like that, all right, you would find this part between these 2 points would be constant. So all you have to do is find what numbers they are on the graph. So let's say it's -2 to 1, 0 to 1. All right, it's constant between -2 and 1. Here is your increasing. So once again, just find out what 2 points these are, and that's where it's constant at on the x-axis. And then decreasing right here. This is decreasing. So just find once again what these values are, and that's what you're going to plug in. So pretty easy. Odd or even, that depends on x values. If you're able to, well here, x squared would be an even, x to the third would be an odd, all right? If I put a -1 here, all right, it doesn't change this. So if x is -1, -1 squared is still 1. If I put regular 1 in here, 1 squared is still 1. So that doesn't change, it makes it even. Here, if I put -1, I get a -1 because it's -1 times -1 gives me positive times -1. Here, -1 times -1 is a positive. But once I multiply it by another negative, that gives me a negative. So in this case, it would be changed. So 1 times 1 times 1 equals 1. -1 times -1 times -1 equals -1. So they flip, they're changed. So this is odd. Even, odd. All right. Page 7. Inverse functions. Find inverse of f of x equals x plus 5 over 7. All right, just follow these few steps and you should be able to get it. It's kind of weird, but this is the way it works. So the first thing we do, step one, replace f of x with y. All right, so here's f of x. Just put a y in it, make it look like a regular problem. All right, so y equals x plus 5 over 7. All right, step 2. Swap y with x. Y and x, flip them. So x equals y plus 5 over 7. All right. And step 3, solve. So I got 7 divided over here. I want to get it on the top side, so I multiply, right? So 7x is equal to y plus 5. All right, all I did was go 7 and then 7 over here. Those cancel. I'm left with 7x. Now I got to get y by itself. All right. So I'm just going to subtract this 5 away from it. So minus 5, and I'm left with, I'm going to flip it over. So y equals 7x minus 5. All right. Now what I have to do is to make it an inverse, I've got to put it back into that f of x kind of notation, but I'm going to put a negative instead. So I'm going to get rid of my y. I'm going to put f of negative 1x equals 7x minus 5. And that's how you do the inverse. Page 8. 2 more pages. Come on, focus. Standard form of equation of circle. All right. Equation x minus h squared plus y minus k squared equals r squared. All right, so if I told you the center of my circle is at 0, 0, and the radius equals 2, I can go ahead and solve for this. Now, the h and the k, that's like your x and y. So here's your h, here's your k. So now we know what to plug in. So all I have to do is just plug this stuff in, and I'm good. On the exam, all they want is it. They just want it in this format. So x minus 0 squared plus y minus 0 squared equals, and I'll just plug that part in real quick. So that's going to be 4. That's it. Piece of cake. Now, if they wanted you to, you could go back and try and break this down a little more, but you know that's all they want. So that's all you do. Slope intercept. Whoop. Slope intercept form parallel to a line. That's what we're going to be doing. Parallel to a line. Now this one's easy. We almost don't even have to do any math. Just remember the equation that you're looking for. Remember it's y equals, well, I'll just put a problem in. Y equals 1x minus 4. All right. Remember, this is your slope. This is your y-intercept. All right, that's all we need to know. Remember, your slope is a rise over run. So remember, these numbers are really like this 1 is really a 1 over 1. So it's up, over. 1 up, 1 over. 1 up, 1 over. 1 up, 1 over. All right. If it was a 2 to 1 slope, then it would be 2 up, 1 over. 2 up, 1 over. So that's all you got to remember. All right. So we know where the y-intercept is, so we could really just plot this and then go from there. So let's just do it nice, because that way you don't have to do any math. All right, so in this case, I'm gonna go -4 down. So 1, 2, 3, 4. There's my y-intercept, -4, and I have a slope of 1. 1, 2, 3, 4, 5, 6, 7. Let me just put some graph lines down just so we can see a little better. And like I said, make it nice. It'll make your life easier. All right. So slope of 1, 1 over, 1 up, 1 over, 1 up, 1 over, 1 up. Good enough. So there's the 1 line. All right. Now let's say they're telling you find a line another line parallel somewhere over here that crosses through. Let's do 1, 2. All right, so we're looking for a line that's going to cross through that, but is parallel to this. So the first thing I'm going to do is just find this point. So 1, 2, 1, 2. I should have added more lines, I guess. So do. All right, so 1 over, 2 up, 1, 2. All right, I know my line's got to go this way. All right, so all I have to do is just figure out where it's going to hit this point, and I found it right now. See, our slope is still going to be 1 to 1. That's going to make it parallel. So I can just come down 1, 1. There you go. 1 over, 1 up. 1 over, 1 up. That line right there is parallel. So now I know that my intercept, my y-intercept, is at 0.1. 0 on the x, 1 up. So my new formula, my formula that's going to be parallel to it, is just going to be y equals 1x. This part's going to be the same because we need it to be parallel. It's got to be the same slope. All right, and I was just looking for my new y. All right, that was this line. My new y is going to be +1. And that's all you got to do. Keep your graph easy. Plug your slope in, find your y-intercept, and that's what we're looking for. All right, last page. This is it. Page 9. All right. Leading coefficients test. There we go. This is just to determine which way your graph is going. Is it going to be pointing down and this way, or is it going to go down and up, or is it up and down, whatever. All right, so the only thing we have to do is break it down into 2 main categories and then break that down into 2 categories. All right, so we're going to have odds and we're going to have even. All right. Under odd and even, we're going to have positive and negative. Positive and negative. All right. So what we're looking for is, let's look at a couple things. Let's say we have x to the thirds, x to the fifths, x to the seventh, x to the ninth. All right, these are all odds. Odd, 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 odd. All right, that's what we mean by odd. Over here, x squared, x to the fourth, x to the sixth, x to the eighth. These are all evens. X squared, that's 4, that's 6. These are evens, all right? So that's what we're looking at, all right? Now, we could also have negative x to the third, negative x to the fifth, negative x to the seventh, negative x to the ninth, so on and so forth. You get it. If this number is an odd number, it falls under the odd category. If it's an even number, it falls under the even category, all right? So negative x squared, negative x to the fourth, negative x to the sixth, negative x to the eighth, so on and so forth. Now, the only thing we have to do now is just figure out what direction the graph goes. All right? So, and you know what? As an example, let me show you one more thing. This is negative x to the third, but if I had negative 2x to the third, that still falls under the negative category. All right, so this makes it odd. This in front of it makes it positive or negative. All right, so let's just do just show you an example. If it is odd, there it goes, odd and positive. This is a positive x3. Our graph is going to point downwards and do something in the middle, doesn't matter, and then point back up. All right, so we know our graph is going to look like that. If we have, if it's odd and negative, it's going to point up, do some craziness, and then point back downwards. All right. Even. If it's positive, it's going to point up, do whatever it needs to do, and point back up. Let's make that better. There we go, point back up. If it's negative, it's going to point downwards, do whatever it has to do, and then point back down. That's really all you need for the problem. If you can see that that's the way the graph goes, that's all you're going to need. So just use this chart to figure out if it's going up or down, and then you should be fine. I don't think I have another example. Oh, yeah, I do. Here, hold on. I'm going to flip this over. So let's see. X to the fourth plus 2x squared minus 3x.